Let's jump right into this explainer. Today, we're taking a completely fact-based, grounded look at humanity's future over the next 75 years. We aren't dealing in science fiction here. Everything we're about to explore, from the restructuring of the global population and the dawn of artificial general intelligence, to rewriting our own biology and literally colonizing Mars, is drawn directly from current scientific evidence, real-world clinical trials, and verified industry timelines. Today, we are opening the blueprints of tomorrow.
To really grasp the stakes of where we're heading, listen to how Ilya Sutskever, the co-founder of OpenAI, puts it. He calls this the exciting, perilous journey toward AGI. That right there is the exact tightrope we're walking. You have this massive, utopian economic potential balanced right on the edge of profound existential risk. And that's exactly the path humanity is on between now and the year 2100.
All right, part one, the demographic tipping point. Humanity's changing baseline.
Before we get into the wild technology of tomorrow, we have to look at the people building it. The 21st century isn't going to be defined by a massive population boom like in the past. Instead, it's about structural aging and an eventual historic decline. Look at the data from the UN's World Population Prospects. We're sitting at about 8.2 billion people today, right? Well, that is projected to peak at around 10.3 billion in 2084 before actually entering a steady contraction, dropping back down to 10.2 billion by 2100.
So, what's actually causing this unprecedented shift? The science points to three big macroeconomic drivers. First off, the global growth rate is dropping fast. It's expected to hit negative 0.1% by 2100. Second, the global total fertility rate is falling below the replacement threshold of 2.1 births per woman. People are simply having fewer children. And finally, we are getting older as a species. The median age is expected to climb from just over 30 today all the way to 42.1. Basically, our kids are looking at a future with smaller workforces, changing economies, and a fundamentally different society.
And this demographic shift is going to be drastically uneven across the globe. Because of a seriously rapid collapse in fertility rates, China's population is projected to basically get cut in half, plummeting from 1.4 billion today to just 600 million by 2100. At the same time, almost all global growth will be driven by lower-income countries, while other regions age and decline.
Moving on to Part 2, the arrival of AGI, building digital superintelligence.
With a shrinking and aging human workforce on the horizon, our reliance on technology is going to become absolute. To really get what's coming, we need to define the most disruptive milestone we are rapidly approaching. Shane Legg, the chief AGI scientist at Google DeepMind, describes minimal AGI as an artificial agent that can reliably perform the full range of cognitive tasks an average human can do without failing in surprising ways. We are way beyond autocomplete chatbots here. We're talking about true autonomous agentic reasoning.
And the timeline for this is shrinking incredibly fast. The industry leaders building this stuff are actually reaching a breathtaking consensus. OpenAI's Sam Altman says AGI could hit between 2025 and 2027. Futurist Ray Kurzweil says 2029. Demis Hassabis at DeepMind estimates 2030. Even the more conservative academic researchers like Turing Award winner Yoshua Bengio put it between 2035 and 2050. The bottom line is, human-level machine intelligence is very likely arriving within the next decade.
The implications here are staggering. It's the ultimate double-edged sword. On one hand, scaling these models could autonomously generate extreme economic value. We're talking about automating massive swaths of software engineering, supercharging quantum computing, and completely redefining future jobs. But on the flip side, leading experts are sounding the alarm on profound alignment and safety risks. If these systems transition rapidly from AGI to superintelligence, which some say could take as little as 2 years, making sure they actually operate safely and share our values becomes literally the most critical challenge of our time.
Part 3. Physical AI and Smart Cities. The world becomes automated.
AI isn't just going to live inside a server somewhere. It is breaking out into the physical world. Humanoid robots and self-driving cars are actually converging on the exact same hardware and software to make this happen. They both rely on VLA models, that's vision, language, action, giving machines the ability to see the world, understand it, and physically interact with it. Combine that with multimodal sensor fusion like cameras and LiDAR and high-performance edge computing, and you've got a shared foundation that is massively accelerating their rollout across our cities.
Let's trace how this chronologically plays out. Today, we're seeing humanoid prototypes that cost around 150 grand. But as those costs fall, analysts predict that by 2030, we'll see the rise of dark factories, places planned by companies like Hyundai and Boston Dynamics that are run literally 100% by robots.
Fast forward to 2040, and we're looking at regional passenger eVTOL networks, essentially flying vehicles shaping everyday transit. And by 2100, these autonomous systems will be seamlessly wired into smart city grids, optimizing traffic, waste, and power in real time.
Part 4. Rewriting Human Biology, Enhancing the Human Machine.
While the machines are upgrading, we are simultaneously learning to upgrade our own hardware. Brain-computer interfaces, or BCIs, are already a clinical reality. Just look at Neuralink's ongoing PRIME study. The process involves an R1 surgical robot mapping the brain's blood vessels to avoid damage, and then precisely inserting 64 flexible polymer threads into the motor cortex. Those neural signals are then wirelessly decoded, which is actively allowing paralyzed patients to control computers simply by thinking. It's truly incredible.
But the long-term vision of this technology goes far beyond medical restoration. Neuralink's roadmap moves from products like telepathy for digital control and blind sight for restoring vision toward a highly ambitious ultimate goal, creating a true symbiotic link between human cognition and AI. By 2100, high-bandwidth neural implants could fundamentally reshape human capabilities, granting superhuman perception and processing speed. The very way you communicate, learn, and experience reality could completely change.
And this massive paradigm shift extends right into biotechnology, where clinical trials are actively pushing the boundaries of longevity. Verve Therapeutics is using in vivo base editing to permanently lower cholesterol by changing single DNA nucleotides. Life Biosciences initiated trials using epigenetic reprogramming to basically reverse biological aging in optic nerves. And researchers at the Salk Institute have already used CRISPR to suppress aging in mice, extending their biological lifespans by 25%. The medicine of tomorrow isn't just about treating disease, it's about rewriting the source code of aging itself.
Part 5. Energy and Planetary Engineering, Sustaining the Future.
Now, running millions of AI servers, electric cars, and entire smart cities takes a staggering amount of power. It's setting up a 21st century race between clean energy and planetary scale risk. On the energy side, companies like Helion are targeting commercial fusion power grid integration as early as 2028. If that succeeds, we get near limitless clean baseline power. On the flip side, if climate targets fail, organizations are heavily researching geoengineering, technologies like mass carbon capture or solar radiation management. Sure, they could cool the Earth, but these planetary-scale interventions carry massive, completely unpredictable risks to global weather systems.
Finally, Part 6. Humanity's Interplanetary Future, Becoming a Multi-Planetary Species. Driven by the need for resources and a desire to safeguard human civilization against planetary risks, we are witnessing an awe-inspiring push into the cosmos. And the timelines between national agencies and commercial space operators are wild. NASA's Artemis program plans to circumnavigate the moon in 2026, land humans by 2027, and work toward a permanent lunar base. Meanwhile, SpaceX is pushing an aggressively compressed timeline, aiming to land the first crewed starship on Mars by 2029, all to lay the groundwork for a self-sustaining Martian settlement by the year 2050.
1 million people. By the year 2100, that is the ultimate ambition of this interplanetary push. SpaceX's stated long-term objective is to have built a permanent, self-sustaining city on Mars, boasting a population of 1 million people. Just imagine that, an entirely new branch of human civilization, living and working on another world.
The blueprints for all of this are actively being drawn right now. From a shrinking, aging global population and the blindingly fast arrival of AGI, to robots in our smart cities, and humanity branching out to Mars. The seeds of 2100 are being planted today in laboratories, clinical trials, and launch pads all over the world. So I'll leave you with this final, profound question to consider. When the reality of tomorrow finally arrives, will we be ready for it?